Hello, my name is Jesus Garcia. This is my third semester. I'm a sophomore. DC Circuit is the course I'm taking. And in this video, I will be explaining on how my lab works and how the circuit works. First, we start with the multimeter. We connect the multimeter to the black and red wires, and these wires connect to the breadboard, which is also followed the resistor, which allows us to see how much electricity is being put out by it. As you can see here, it says 0.987 ohms. In this next example, you can see it puts out 0.0 L milliohms. The reason it does this is because the wires that are connected to the breadboard are not near a resistor, which means they do not receive any resistance of electricity towards them, which the multimeter can't read, as you can see. In here, it's fairly easy to understand why. It's because there's nothing going against it, nothing resisting the current, so it wouldn't read anything. In the last example, we measured what the energy output would be on the right, and now I decided to move it to the left. As you can see, from us moving it to the left is actually less energy than the right, which can contribute to the circuit board. And the way we could tell this is because if we go back to the multimeter, it has different units which equal either a smaller number or an equal number. In this case, we just have regular ohms, and in the other one we have mega ohms. When looking at the multimeter, we get 0 point nothing because we are only connected to the wires on the breadboard. Having no resistor around means no energy is being outputted or any electricity is being held. This made me curious. What if we were to put two resistors next to a wire, and what would the multimeter say? So for that, that's exactly what I did. I put two different resistors. They both read the same ohms, but have different values in them. For example, the one on top reads 2.0 k ohms, while the one in the bottom reads 3.3 k ohms. Once you do the calculations, you're able to know how much energy is being resisted. That calculation, percent error, equals the value that was measured minus the value that was expected. Meaning, whatever the multimeter reads from this, you would subtract from the value expected. If it was the one on the bottom, it would be whatever you measured minus 3.3 k ohms. And then you would divide by the value expected and times it by 100. In this multimeter, we read 10.0 ohms. I decided to move the wires a bit and play with them, and this is what I got. What is a closed circuit? A closed circuit is a continuous, uninterrupted path through which an electric current can flow. A good example of this would be when you flip the light switch up and it turns on your light. An open circuit would be a perfect example of when you flipped your light switch down and now it's an open circuit, not letting the electricity run through and turn your light bulb on. And that's all I have for you guys. Bye for now.